Okay, good morning. Welcome back. In the last class, we have discussed about the types of wireless LAN. First one is your ad hoc mode. Second one is your infrastructure mode. So, in the ad hoc mode includes wireless LAN cells interacting without connecting to wire networks and without connection to an access point. No access point is needed, and the devices might connect to the internet through wire or other wireless techniques. And there is no fixed infrastructure, and information is forwarded in peer-to-peer mode. There is no administration, no setup, and no cost. Each node can directly communicate with another node. Nodes can only communicate if they reach each other physically or if other nodes can forward the message. And this network structure may operate in a standalone fashion. Each node is equipped with a wireless transmitter and receiver with appropriate antenna. Next, you can say the infrastructure mode. It includes one or several interconnected wireless LAN cells which are connected to a fixed net through access point. Wireless access points can be compared with an Ethernet hub or switch and is used to allow computers or other devices with wireless cards to participate in a network. All communication occurs through access points. Communication typically takes place only between the wireless node and the access point and not directly between the wireless node. Access point, you can say, acts as a bridge. Access points with a fixed network can connect several wireless networks to form a larger network beyond the actual radio coverage. Design the simple because most of the network functionality lies within the access point, and collision may occur if medium access of the wireless node and the access point is not coordinated. And there are, in this type of communication, there are two type of access points are there. One is your hardware access point, one is your software access points. So in the hardware access point offer comprehensive support of most wireless features, but the requirements should be checked carefully. But software access point which run in a computer equipped with a wireless network interface card as used in an ad hoc or peer-to-peer wireless network. So next is the ad hoc mode. In the ad hoc, networks are created between two or more wireless pieces together without the use of wireless router or an access point. The computers communicate directly with each other. Ad hoc networks can be very helpful during meeting or in any location where a network does not exist and where people need to share files. So generally in the ad hoc network is device having own capability to maintain that network. There is no infrastructure, intermediate devices is required to communicate with each other. So in the ad hoc network, basically you can say in the ad hoc network there is no administration, no setup, and no cost. Each node can directly communicate with another, like peer-to-peer architecture, and nodes can only communicate if they reach each other physically or if the other nodes can forward the message. That is the ad hoc network. Next, known as the infrastructure mode. What do you mean the infrastructure mode? A network infrastructure is the hardware and software resource of an entire network that enable network connectivity, communication, operation, and management of an enterprise network. It provides the communication path and services between the users and process, applications, services, and external networks and the internet. That is the infrastructure includes one or several interconnected wireless LAN cells which are connected to a fixed net through access point. Wireless access points can be compared with an Ethernet hub or switch and is used to allow computers or other devices with wireless cards to participate in a network. All communication occurs through access points. So in this infrastructure mode, Several interconnect wireless LAN cells which are connected to a fixed net through access point. Wireless access points can be compared with an Ethernet hub or switch and is used to. That means the intermediate devices are used to communicate in this type of infrastructure mode. So here the number of the systems and the intermediate devices is used to communicate with each other, or you can say all the devices are connected through that intermediate devices. And next is this is the standard of IEEE 802.11. is a part of the IEEE 802 set of local area network LAN protocols and specifies a set of media access control MAC and physical layer protocols for implementing wireless local area network, Wi-Fi computer communication, various frequencies including but not limited to 2.4 GHz, 5 GHz, 6 GHz and 60 GHz frequency band. So the IEEE adopted the first standard of wireless LAN. As the standards number indicates, the standard belongs to the group of 802.x LAN standard, and this means that the standard specifies the physical and medium access layer adapted to the special requirements of wireless LAN, but offers the same interface as the others to higher layers to maintain interoperability. The primary goal of the standard was the specification of a simple and robust wireless LAN which offers time-bounded and synchronous services. The IEEE 802 committee was formed to set up the standard of LAN domain. There are many standards within this family with almost all letters from A to X. So these specifications defines an over-the-air interface between a wireless client and a base station, or between two or more wireless clients. More popularly, 802.11 is known as Wi-Fi. But before we get too far into where 802.1 is going, let's discuss about the different standards of 802.11. These are the standards. 802.1 on applications to wireless LAN and provides 1 or 2 Mbps transmission in 2.4 GHz band using either frequency hopping spread or direct sequence spread spectrum and FHSS. Next is your 802.11a, an extension to 802.11 that applies to wireless LAN and provides up to 54 Mbps in the 5 GHz band. 802.11a use an orthogonal frequency division multiplexing encoding scheme rather than FHS or DSS. Next standard is 802.11b, also referred to as 802.11 high rate of Wi-Fi, an extension of 802.11 that applies to wireless LAN and provides 11 Mbps transmission with a fallback to 5.5, 2 and 1 Mbps in the 2.4 GHz band. 802.11b use only DSS. 802.11b was in 1999 ratification to the original 802.11 standard, allowing wireless functionality comparable to Ethernet. Next is 802.11e, a wireless draft standard that defines the QoS or quality of service support for LANs and is an enhancement to the 802.11a and 802.11b wireless LAN specification. 802.11e adds QoS features and multimedia support to the existing IEEE 802.11b and IEEE 802.11a wireless standard while maintaining full backward compatibility with these standards. So these are the regarding the quality of the service, and the next class we will discuss in the another standards. So for now, thank you to all.